Hello everyone. Welcome back to today's math journey. Let's start with a thought. Have you ever noticed how nature loves patterns? The petals on a sunflower, the spirals in a pine cone, or even the holes in a honeycomb, they all seem to follow some magical order. Now, in our everyday life too, we see patterns. For example, the steps of a ladder, the increase in a person's salary, or the money saved every year, they don't grow randomly, they grow in a predictable way. And that's exactly what leads us into today's topic, arithmetic progressions. An arithmetic progression, or AP for short, is simply a sequence of numbers where the difference between consecutive terms is always the same. In symbols, we write it as A plus D, A plus 2D, A plus 3D, and so on. Here, A is the first term and D is the common difference. So let's explore how APs show up in real life. Imagine this, Reena gets her first job. She starts with a monthly salary of 8,000 rupees and every year her salary increases by 500 rupees. So in the first year, she earns 8,000. In the second year, it becomes 8,500. In the third year, it's 9,000. And then 9,500 in the fourth year. Do you notice the uniform jump of 500 each time? That's an arithmetic progression. The first term A equals 8,000 and the common difference D equals 500. Now, how do we calculate her salary in the nth year? We use the general term formula A sub n equals a plus open bracket n minus 1 close bracket into D, substituting the values A sub n equals 8,000 plus open bracket n minus 1 close bracket into 500. This formula can tell us the salary in any year, even the 20th year, without listing all the salaries in between. Let's climb a ladder now, literally. Suppose the lowest rung of a ladder is 45 centimeters long and each rung above is 2 centimeters shorter than the one below it. That means the first rung is 45, the second is 43, the third is 41, and it continues 39, 37, 35, 33, 31. This is again an AP, but notice here the common difference is negative. Our first term A equals 45 and common difference D equals minus 2. So, the nth rung length is given by A sub n equals a plus open bracket and minus 1 close bracket into D, that is, A sub n equals 45 plus open bracket and minus 1 close bracket into minus 2. For the 8th rung, substitute n equals 8. We get A sub 8 equals 45 plus 7 into minus 2, which equals 31. Perfect match with our sequence. Now let's talk about Shakila, who had a smart savings idea for her daughter. On her daughter's first birthday, she put 100 rupees in a money box. On the second birthday, she added 150. On the third, 200. And so on, increasing the amount by 50 rupees every year. So the sequence goes 100, 150, 200, 250, and so on. Here, first term A equals 100 and common difference D equals 50. The general term becomes A sub n equals 100 plus open bracket and minus 1 close bracket into 50. If we want the amount added on the 10th birthday, we just plug in n equals 10. That gives A sub 10 equals 100 plus 9 times 50, which is 550 rupees. That's how predictable patterns make savings easy to track. Now, here's something interesting. Not all patterns are arithmetic progressions. Take this example, the number of unit squares in a square of side 1, 2, 3, and so on. The numbers go as 1, 4, 9, 16, and so on, which are square numbers. The differences here are 3, 5, 7, not constant, so this is not an AP. Or think of rabbits producing pairs each month. The sequence goes 1, 1, 2, 3, 5, 8. This is the famous Fibonacci sequence, not an AP. Moral of the story? Always check if the difference between consecutive terms is uniform. If it's constant, it's an AP. If not, it belongs to some other pattern family. Alright, let's go a little deeper and derive the formula for the nth term of an arithmetic progression. Let's start with the sequence a plus d, a plus 2d, a plus 3d, and so on. Now, the first term is a. The second term is a plus d. The third term is a plus 2d. We notice a clear pattern. Each time, we are adding d one more time. So, the nth term must be a sub n equals a plus open bracket n minus 1 close bracket into d equation 1. Let's check. If n equals 1, then a sub 1 equals a correct. If n equals 2, then a sub 2 equals a plus d perfect. So, we have derived the most powerful formula of AP. A sub n equals a plus open bracket n minus 1 close bracket into d. And this formula will unlock almost every AP problem we'll solve ahead. So, let's wrap up today's journey. An arithmetic progression is a sequence with a constant difference between consecutive terms. Its general nth term formula is a sub n equals a plus open bracket n minus 1 close bracket into d. We saw real-life examples like Rina's salary, ladder rungs, and Shakila's savings, all clear ARPs. We also compared them with non-ARP patterns like squares and rabbits to understand the difference. And most importantly, we derived the formula for the nth term, which is the foundation for deeper studies in AP. So, that's the exciting beginning of arithmetic progressions. In the next video, we'll explore how to find the sum of the first n terms of an AP, another powerful tool with amazing applications. See you there.